Drone Technology is a 7-week, 2-credit course designed to immerse students in aerial photography and videography and photogrammetry and image processing. The instructional objective of this course is to increase opportunities for undergraduate students to safely and purposefully operate drones and acquire and analyze aerial imagery and sensory data for use in their academic coursework and research. The course will begin with a 2-week instructional period, 3 hours per day, during interterm, followed by 5 weeks of flight training. The course encourages teamwork, critical thinking, and perseverance, and will best suit the motivated student who thrives in a project-based and team-oriented learning environment. The learning environment for this course will be a blended, facilitated approach with readings and video tutorials assigned outside of class and lectures, demonstrations, and performance-based activities taking place in class. Class instruction and demonstrations will take place in the Spatial Analysis Lab. The lab has 21 Windows machines with photogrammetry software, data projector, sound system, and roundtable for seminar presentations. Indoor flight operations will take place in Scott Gymnasium, which hosts an open floor plan with caged lighting and preventative netting enclosure. Outdoor flight operations will take place at the McLeish Field Station for environmental research, which has open field and level terrain acreage suitable for drone flight. The course will be hosted on Moodle, the college's course management system, and will be divided into 4 modules: Introduction to Drone Technology, Pre-flight, Flight, and Post-flight. Each module will be divided into 3 sessions each, with specific learning objectives, activities, and assessments. The instructor will differentiate content, processes, and products by providing assignments and questions that students can prepare beforehand, using visual aids during demonstrations, providing prompt questions to help students focus on the most important elements of assigned readings, providing group work opportunities, allowing all students to use course resources when taking quizzes, and periodically reviewing material covered in previous demonstrations and activities. For example, the Drone Safety and Legal Issues session will begin with a pre-class reading of an article entitled Safe Use of Drones on Campus that clarifies FAA educational drone use. This reading will be followed by a review of FAA unmanned aircraft systems rules and regulations. After these readings, the instructor will introduce sectional charts and demonstrate how to read and analyze the location of a planned drone flight for any impending obstacles or airspace restrictions. Students will then be paired together, access their sectional chart assignment in Moodle, and fill out the accompanying case study worksheet. The instructor will encourage the students to use the Aeronautical Chart User's Guide as a resource. At the end of 20 minutes, the class will reconvene, and each student pair will present their sectional chart analyses in front of the class. The instructor will then demonstrate to the class how to decipher a METAR, a coded weather report issued at hourly or half-hourly intervals and used predominantly by pilots during pre-flight briefings. After the demonstration, students will select one of 6 METAR reports to decode in Moodle, using the METAR TAF abbreviations link to help them decipher the code. When students have completed the exercise, they will submit their worksheets to the METAR discussion forum to share with the class. The session will end with gameplay by dividing the class into 2 teams, Team Phantom and Team Pro. The game is Drone Jeopardy! And the categories will include drone use in higher ed, drone anatomy, FAA rules and regulations, sectional charts, and METAR TAF reports. Team members may confer with one another to come up with a response that needs to be phrased in the form of a question. During class and field exercises, the instructor will circulate among teams to observe students' interactions with one another, their grasp of course content, and their problem-solving processes. These formative observations will provide the instructor an opportunity to assess students' understanding of course content, as well as evaluate the scaffolding of course activities and the effectiveness of assessments. Overall, the efficacy of the instructional strategies and technology tools used in this session will be measured by student accessibility to course content, student interaction with technology, and student performance. Moodle Analytics will provide data on student access to and success rate with course exercises, such as the introductory readings, the Drone Safety and Legal Considerations quiz, and the Drone Anatomy quiz. Moodle data will also reveal if and when students utilize the session checklist and activity completion checkmarks.